Hi guys, thank you for joining this webinar. Myself, Anas Ajaz from QuickStart, and our instructor, is presenting this webinar. She is a certified Netapp instructor, and she has a vast experience in the Microsoft side as well, Deepika and Aja. So we'll be starting this webinar most probably after 1-2 minutes. Let's wait for a few more attendees to join this this webinar. Thank you.
Thank you so much, guys, for coming in. I'm Deepika and Aja, and I will be going over this webinar with you guys. So like I mentioned, we will wait for more participants to come, and then we'll start rolling, okay? Anas, let us know when you think is the right time and we can start the presentation.
For sure, for sure. Just wait for 1
Thanks.
minute or so. Yeah, thank you. Guys, please bear with us for just a more minute. Thank you. Yeah, I think it's the right time to start. Deepika, could you please take it over from there?
Sure. Thank you. Thank you. So a very warm welcome to all of you guys. Thank you so much for joining us in, for getting a sneak peek on what are SVMs in cluster management in Netapp world. I hope you guys are like familiar about Netapp. What we are learning here is SVMs. And before I take you to the world of SVMs, it's very important for you to have an idea about what cluster is in the Netapp world. So basically, when we talk about a cluster in the Netapp world, guys, you know, there are lots of things. So we're going to cover, like we may not be able to go in detail, let me tell you up front, because of the time, limit, but we will definitely give you a full idea about what are SVMs and everything related to it. Not everything, but I would say the most important things. Let's get going. The very first thing, let me turn on my slides and we should be starting right now. So what are we here for? Learning role of SVMs in cluster management. Now, before I take you to the world of SVMs, a quick overview or a quick introduction from my side. My name is Deepika Aneja, as mentioned. I'm into IT since 1990s, and I do Microsoft, Netapp, all different types of courses. I mean, we do consulting, we do teaching, and I started with back in 90s when it used to be Microsoft Windows NT4, and then we realized that storage is like so important. And then slowly I moved on to storage side, and I do have all these different certifications and I teach all these technologies. And today we are here for discussing the Netapp aspect called SVM. Now, SVM, why we picked up this topic was because it is a very, very important topic to understand, because the only way to serve data in Netapp cluster is through SVM. So that's the reason we thought this would be the most important piece. And lots of times when we are like consulting or teaching, people take time to understand this because it's something like they would like to spend more time on. So it would be a nice opportunity to have a sneak peek on what is this SVM. So like I mentioned, the very first thing before I can take you to the SVM world is to give you a quick brush up on what is cluster in the Netapp world. So this is the agenda of our 1-hour presentation, that we will first try to have an idea about what is a cluster in Netapp. because you may have come from Windows or different background, and you probably have a definition which is slightly different than what Netapp has. So it's very important to first understand the cluster. Then only you will feel that what is actually the need for SVMs. SVM has lots of characteristics. Like I mentioned, even if we won't be able to cover everything. But the most important piece of SVM is, like, how to create it. And what are the two pieces? Like, you will always have to attach it with a port. So we will talk about ports and lifts in our presentation today. Then what are the different types of SVM? Yes, SVM can also be categorized into different types. Then what is SVM root volume? Finally, the benefits. I've thrown a poll question just to have some fun and see how much you guys understood after this whole discussion, a small question. And then I will also give you a demonstration on the steps which we can use to create SVM. For that, I'm going to use my on-command system manager. If you're familiar with that tool, there are other ways also to create SVM. So, like, but I'm going to show you with System Manager. So let's get into, now, the very first thing, like I mentioned, is that we all have to understand what is a cluster. So when you are new for the storage world, you are told that, we have to make a cluster. What is a cluster? In Netapp definition, or the Netapp terminology of cluster is, it is one or more FAS. Guys, I expect you have this basic understanding. If not, FAS is basically fabric attached storage, also called filer, also called storage controller. So in this picture here, if you notice, you are looking at a pair of FAS here, another pair of FAS here, and the other pair of another storage controller here. So please understand the idea behind this picture is to teach you that this cluster in this picture is actually comprising of 6 nodes. Yes, guys, there's a lot to talk about cluster itself, but cutting it short, cluster is series of pairs. But I also mentioned that even one node, it's an exception. Yes, you could have one node cluster as well. But in the real world, if you want high availability, fault tolerance, you would at least start with a pair. Okay, so in this example, what they're trying to teach you is, and also each FAS or each storage controller, in the Netapp terminology, we call it node. So how many nodes are in this particular cluster? In this particular example here, we have 6 nodes. And how many pairs? They always work in pairs. An exception is one node. So yes, guys, this is what we call a cluster, and you will always give it a name, let's say cluster 1, and this cluster is comprising of 3 pairs, 6 nodes, all together looked at as one cluster. There can be a lot of discussion happening here that how these 2 nodes, which are making a pair, will be connected through a special cable called HA interconnect, like a heartbeat, how they talk. So when we talk about pairs, they're already connected to each other at the back, which they're not showing here. Plus, there is another connection here, which is also called the cluster interconnect, which connects every node and every pair together to make it aware that it is participating in one cluster. So this is the definition of cluster, that when clients want to come in and access data, now what? As a storage admin, you would like to hide the complexity, what's going on inside the cluster. You do not want to expose to the outside world that if some data is being served to them, they don't need to know which node is serving them. That is where we need help of virtualization, which means I don't want to show them anything physical happening inside, okay? So how do you serve data to the clients? That is when the storage admin, who is also probably the cluster admin in this example, would create what we call as a SVM. SVM is logical. It's called storage virtual machine, Also, if you're coming from the older versions of Netapp, ONTAP, we also call them vServer. So please understand vServer and SVM means the same. Okay, and yes, the new name is SVM, but if you are managing a cluster from a command line interface, I hope you understand when I say command line, I'm talking about like one of the tool which we oftenly use is PuTTY. So if you are connecting through PuTTY to this cluster and you want to see all the SVMs, there is still the command, they didn't change the command, and the command still is vServer show. So please understand, on command line, SVMs still appear as vServers. Okay, so be careful. They both mean the same. Coming back to my discussion, why do we need SVM? Basically, think about SVM like this is my implementation or my interpretation, that SVM is like a tray. SVM is like a tray in which I will serve you the data. So please understand, when clients connect, they don't need to be told, go to node 1, go to node 3, go to node 5. No, they will be asked, what do you want to access? Oh, I need to access a volume which is connected to node 1 here, this volume. Okay, fine. You will create an SVM and attach that volume with the SVM, and here you go. And what will clients connect to? Clients will always connect to SVM. Now, the beauty is that when clients connect to the SVM, they think they're connecting to another FAS, another storage machine, another controller. That's how we make this SVM appear to the outside world, that, oh, you just connected to a machine. They don't need to know that it is just a window to come into our cluster and get you what you want. You will always have an experience as if you're connecting to a machine. And that is the reason, though logically you gave a name and you connected all the volumes which needs to be served to these clients, you will also have to assign this SVM an IP address. Now, when we need to attach an SVM with an IP address, again, I cannot tell the clients the IP of the physical port here because I want to hide all the physical aspects. Okay, so what do? From the physical networking point of view, what we create is what we call is a logical interface. Logical interface, which means a virtual IP address, which will point to that port on the node which is serving them data. But they don't need to know. They will always know the name of the SVM, and they will always be given this virtual IP. When clients connect, and obviously guys, SVM names will be registered in, if you are having some Microsoft background, we will have to register this name as if it was another machine. And the clients, when they connect to SVM, they can either connect to an SVM or this virtual IP address, also called the logical interface. And this is how they will get what they need to see. And that's how they are happy. The whole reason of doing this all work is that tomorrow, if you moved your volume from one node to the other, the people don't have to be, or like basically end users don't have to be told that no, use something else. Why? Because they're still connecting to the same SVM, same IP address. The only difference is that this IP address which they're connecting is now taking them or redirecting them to another physical port somewhere in the cluster. So that is the whole beauty, that with SVMs, if you had to take a node down for maintenance, for upgrade, there is no problem because you move the data and the other node can still serve them the data, and they will never feel that their data move to another place because they were always getting what they want out of the cluster. So that's the whole foundational, basically understanding of why we need SVMs. We don't want end users to know anything inside my cluster, my physical node, the physical ports. So what we show them is a storage virtual machine, which appears like a storage controller, and we will give a virtual IP, which actually is connecting to some physical port somewhere, and that's how things work. So it is the storage admin who would be doing all these pieces. And there are other advantages which I'm going to go over, but is it making sense, guys? Any questions? Any questions? Are you all understanding? So far, so good? So far, so good, guys? Okay. So keep moving from here. So they're just trying to tell you, like I mentioned, that cluster could be one or more than one node connected through, like depends if these are there, here is it's like series of pairs. They're connected through cluster interconnect, which makes them participate in the same cluster. Now coming back to the next thing, like talking a little bit more about SVMs, I hope it's the main message is sent across that we do need SVMs, which is actually the right terminology is storage virtual machine, because isn't it like you are partitioning your cluster based on the requirements? So it is a fundamental unit of secure multi-tenancy. It enables partitioning of the storage infrastructure so that it appears like multiple independent storage systems. And by that, you're isolating data that this department has this SVM, this department has this SVM. Each SVM appears as a single independent server to the outside world, which enables multiple SVMs to coexist in a cluster. And you should know that they are so independent that they are so independent that they don't share things. So each SVM is independent on its own. Think about a very good example here would be if you are talking about storage on cloud. If you are having storage on cloud, what do you think? AWS or Microsoft Azure, they probably have one SVM for every company, right? That's how they're dealing with it, probably, that because they don't want each company to share anything, so they have given you, and they don't need to tell you what the infrastructure they have. So what they offer you is a kind of an SVM. Okay, again, SVMs are also or were also called vServers in the past, but today also the commands are still like, if you are using a graphical interface, guys, what is the most popular graphical user interface to manage Netapp? On Command System Manager. What is the most commonly used command line interface to manage Netapp? It is PuTTY. So if you're sitting on command line, you still see vServers. If you're on the new GUI tool, you will see them as, but they being the same. Now, this is what I was talking about, that if you have decided that I am planning to have multiple SVMs, which will serve data to multiple clients, the next challenge would be, how can I give a virtual IP? Now, remember that virtual IP is called a logical interface, and you will give it a name associated with a virtual IP, but that LIF has to point to some physical port. So when an SVM, which is attached to this LIF, when clients connect, it is the cluster which resolves this to the physical port and the IP and takes you there. In this example, guys, if this physical port was down, the clients won't be able to get to the data. So what we generally do in the real world is we group multiple ports, physical ports, and make a group of ports, something like, guys, nick teaming, or there are different terms we used, and then let SVM point to this group, or the logical interface point to this group. What is the benefit? Like, it depends on how you set up this group, but you are getting high availability and fault tolerance because SVM is pointing to a LIF, which is pointing to a interface group. So just try to understand. There's again a lot more when it comes to networking. Okay, so there is a physical port, you can create a group. You could also have virtual LANs used for trunking in between. So there's a lot you could add on. But the main idea to put across is that an SVM always needs two things. What are the two things? Which volume is it serving to the clients? And what logical interface will it be available with? Okay, so these two things are important. Then what are the different types of SVMs? When you are setting up your cluster, let's take an example. Guys, you all most likely know what is ONTAP. If you don't know what is ONTAP, it is the Netapp operating system which we install on our filers. ONTAP, yes. So when you are like, Quick Start offers lots of trainings to get you like, have good experience on ONTAP, and like, there are specialized trainings which they can go through with you if you are interested. But what we talk is that how we can use this operating system to manage our storage. So what you need to understand is, let's take an example that we are planning to have 2 nodes. I'm going to make it in a slightly different way. This time there are 2 separate nodes in 2 different chassis. If I have 2 nodes, they will have HA interconnect and they will also have cluster interconnect. Each node has its own shelf of disks. Okay, now what happens? I want to set it up as a cluster. The very first thing you need to do is install ONTAP on both of them, the OS. Then you go to node 1 and what you do is you say cluster setup. And this time, because you're running it on the first node, you will say, I would like to create first. And then when you come to node 2, you will say, I would like to join to the existing cluster. So guys, this is how you make a cluster. And when you're running this setup, what happens at the back is system automatically creates 2 SVMs. What 2 types of SVM? First is your admin SVM. So this admin SVM gets created automatically when you run cluster setup, and it is only one in the cluster. It represents the whole cluster and it owns cluster scope resources. So basically, if you would like to manage your entire cluster, this SVM can be used to manage. And then on the other hand, it automatically creates 1 node SVM per node. That means in this example up here, on the which I'm drawing here, in this example, I will have 1 admin SVM. And since I've got 2 nodes, I will end up having 2 node SVMs, 1 per node after the cluster setup is all done. So try to understand these 2 SVMs you will never create. They get created automatically to serve you data. This is to manage I shouldn't say serve you the data, but here it basically means to serve you or to help you serve either or manage entire cluster here, to be more specific, and to manage only a specific node at a time. So you will never ever create these 2 SVMs. They will be always created automatically when you run cluster. Now, what is this data SVM? If you see this data SVM, this is the one which you will have to create in order to serve data. So think about these 2 are mainly for management purposes. Managing the cluster, managing a node, but when it comes to serving data to the outside world, you would always create what we call as data SVM. So remember, whenever we talk about, oh, let's create an SVM, by default, it will be data because you will never create these 2. They're already there. How can I see them? Now, if you're on a graphical interface, it doesn't show the admin and the node. So you will have to go to command line and say vserver show. vserver show. And have a look here in this output. It shows you, this is an example of a cluster which is called Sunnyvale. And this is admin SVM, which will be 1 in a cluster. And looking here, there are 2 node SVMs, which kind of tells me that this cluster only has 2 nodes or a single pair. If there were 2 pairs in my cluster, I would see 4 node SVM types. And these are the ones which probably the cluster admin created to serve data, because these are of type. So these will be there by default, but these are the ones which we have to create for serving data. And that's what they're telling you, that in case you would like to serve data, you would need data SVMs. It provides multi-tenancy. Again, it separates resources. And the nice thing is, instead of making a person, let's say there is a department, I don't want the departmental manager to be able to manage the entire cluster. So let him be the manager of an SVM. So it also helps you in delegation that, oh, instead of making everyone cluster admin, they are admins of their SVM and they can't go to any other SVM. Because if you make them a cluster admin, you're giving them way more control. So they have control over all SVMs. Okay. So that's the nice piece that you can delegate control. So far, so good, guys. Any questions? So far, so good? Okay. Remember, guys, whenever you have a question, feel free to speak or chat, put it on chat. Also, there is a question and answer section. Anas can go over that with you at the end that, you can put up some questions later too. Now, coming back to what is an SVM root volume? Now, guys, remember we mentioned that SVM, we know as a storage admin that it is a virtual machine. It's not for real, but end users will always we always make them feel that, oh, it's another machine you're connected to. This is the IP of the machine. Now, every time you work on a node, so basically you're making it appear as a node, okay? So we should know this fact that every node has what we call is a root volume. And that root volume is where the ONTAP is installed. The main OS is installed, oftenly called as Vol 0, if you've known that. Now, because you are imitating that SVM is another node, a machine, clients will always try to say, then if you think it's a machine, where is the root volume? So they have done so, like they have, made the architecture so smooth that whenever you create an SVM, if I say whenever you create an SVM, I assume you understand I'm talking about data SVM. Whenever you create a data SVM, system will automatically create an SVM root volume 2 just to make the users feel that there is vol 0 kind of thing. Oh, that makes them feel more closer to, oh, it looks like another machine. See, it has a root volume 2, which every node has. But you guys know as a storage admin that that root volume is fictitious. It's actually not existing, but it is shown to the end users to make them feel as if there is a root volume on SVM. But the main idea of that root volume is a namespace or an entry point for NAS clients to get into SVM and go down to the volumes. So imagine an SVM root volume, like if this was your SVM root volume, you can actually decide how would you like the volumes to be mounted. Do you want volume 1 and volume 2 to be visible like this, or you want them to be nested like this? So this whole hierarchy which you are creating, and again, all this is accessible through an SVM, and these volumes might be maybe one volume is here, one volume is here, one volume is here. Okay, that's the whole beauty. But you're bringing it all together under one roof. And SVM root volume helps you organize them so that when NAS clients get in, which is always like they always work in file level way, they have no trouble and they can write the path to go down to. That helps them. So it is the root which creates like what we call is junction path, if that makes more sense. Okay, so don't confuse it with vol 0 because we all know that SVM is actually not another machine. It is behaving like another node to the end users. Okay. Finally, what all other benefits we can think of when we talk about SVM? Now, SVM one of the benefit is unified storage. What unified storage means is, again, guys, Netapp was the first in the storage industry to let you manage both protocols, NAS and SAN, on one node. There were storage vendors who used to say that, oh, if you want NAS and SAN are the two storage topologies which exist in the world, and there are some storage vendors which fail to support both together on one platform. But Netapp can allow you to use both of them together on one. And not only one, now you can have an SVM, which is serving NAS clients as well as SAN clients. So whenever you create an SVM, it will prompt you, what type of protocols would you like to use? It all depends on what kind of clients are going to come and access the SVM. Okay, so SIFs is basically another name for SMB. If you know, this is I'm really sorry, guys. There is a railway track next to us, so really sorry for that. Okay, so SIFs is another name for SMB, guys, and NFS is basically what Unix or Linux clients use. So network file system, common internet file system. I wrote SMB because lots of people understand SMB and they just have to know that SIFs is just a sophisticated name for SMB. So this is Windows people using NAS, Unix people using NAS with this protocol. But when it comes to SAN, it's other protocols like iSCSI, fiber channel over Ethernet. And what is the difference between NAS and SAN? NAS is a file level protocol. SAN is a block level protocol. Now, another coming back to, so like that's what I was telling you guys up front when I started this presentation, that there is a lot attached to SVM, a lot. So, you know, it has lots and lots of characteristics which we need to know before we come in, but we are here learning the main concept and the other things we'll build upon. So another benefit of SVM is that they're non-destructive. Like I mentioned, if the node which was hosting the volume was taken offline, the partner in the partner, or I should say in an HA pair, the other partner takes over and the clients still continue to use the same SVM, the same logical IP, and they will not feel any issue. So if you were doing resource migration or upgrading hardware or software, clients will not have any disruption. Tomorrow, if you want to add more volumes in SVM, you want to modify it, you can do that as well. So it's scalable. Security, I know that every SVM is on its own. So, you know, they work independently. Okay, no data flows among SVMs. And another beauty is delegation. What is delegation? That if I want a person in the department to be able to manage that particular SVM, I can delegate control. So lots of times when we are in a cluster and we have a requirement for like a group of people to manage a section of storage, then it's very difficult. But now with SVM, what we do is we delegate control at SVM level versus cluster level. Let's see if any one of you can answer to this question. Which pair of component is a major part of data SVM? So when you create a data SVM, what components do you think you will have to set up? And all this is planning. We will not just go in and create SVM. We will have to make sure that we know which protocols SVM needs to be using, where we have to create a LIF, or you know, at least plan it that LIF will point to some physical port on some node inside the cluster. So remember that SVM is a bridge between end users and the complex cluster. So it's very important that you configure it in a way that from one angle, it shows to the end users as a machine, and from the other angle, it knows where to go in the cluster and get what they want. Okay, so be very careful. So what do you think? We mentioned this when we were discussing. Anyone who wants to make a try? A, B, C, D. Which one do you think, guys? Anyone? What do you think? I heard from one of them, yes. Anybody else? Anybody else wants to try? What do you think are the parts for, or what do you need to be ready with when you create? You're correct. The answer is volume, which the SVM will be serving, and the LIF, which you would be attaching it to the SVM. Because you're attaching the LIF to the data SVM, this LIF is also called data LIF. So this is another like explanation and networking, but yes, SVM needs two things. What volume or volumes are you serving? And what lift will this be available at? Okay, very good. Now I will give you a demonstration on this SVM creation, and we will see if you have any questions about it. Like I mentioned, guys, there is so much about SVM. Any questions you have? Any questions, guys? Anything you would like to ask? Because there is, I understand, we talked about different types of SVMs, we talked about the benefits of SVM, and if you notice that my idea was that you should first know that it is the cluster and the complex infrastructure, the networking, how the data could be on any of the nodes inside the cluster. But if I started telling my end users, go to node 1, and that's where you'll get data. And tomorrow, if I move the data from node 1 to node 2, I have to go back to the clients and say, no, 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 don't come to node 1, now go to node 2. All that is not required because they will not see our infrastructure. They will just see a fictitious environment or a fictitious machine created especially for them to serve data, which is storage virtual machine, also called V server. Now, anything you would like to ask, guys? Yes, anyone? Any questions? Anybody wants to ask anything? Okay. In the meanwhile, what we'll do is we'll move on to our demonstration and see how we actually see our SVMs. Now, when we talk about SVMs, I will be taking you to my lab infrastructure. Now I am trying to use my graphical interface, which is on Command System Manager. Now, this is everyone's favorite tool because it is really good for monitoring, like the basic monitoring, managing, administration. Can't stop myself. There's a lot to talk about this. Now, On Command System Manager has also gone through lots of revisions, and this is the latest look and feel. I know people do complain that we learn one, we are comfortable on one, and now there's another. They have moved things right, left, or menus are on the other side. Yes, but their idea is to make it more user friendly, show you more. Just to give you a quick overview, if you're new to this system manager, this right side has a plus sign and has all the day-to-day tasks which you have to do here. That's really handy. Yes, it will take time if you're new to this version, that you should know where to go and scroll and get to our options. But it's just a matter of some time. Once you know it, then you know exactly where to go. The very first thing which opens up when you open System Manager is the dashboard, which gives you a quick overview of how your cluster is behaving. We are trying to create an SVM. So any guesses, where should I go from the left side? Yes, guys, you see on the left side so many options here. Which one do you think should show me my SVMs? Anybody? Let's see who can guess. Yes, guys, this is System Manager in front of you. On the left-hand side, extreme left-hand side is my tile where there are all my tools. Where do you think I should go to look for my SVMs? Anyone? Anyone wants to guess? Has anyone created SVMs? Okay. Let's go ahead, guys. SVMs will be under storage, which has way more stuff, but we will be looking at SVMs. And when I click SVMs, it will show me the existing SVMs here. Oops, these are only data SVMs. Where is my admin SVM? Where is my node SVM? By default, it doesn't show up here because it's created automatically and you don't mess up with it. So that's the reason in the graphical interface, it only lets you create new and shows you the ones you created. But if you would like to see the SVMs which are already created like admin and node, for that we can use a command line tool, and we always love we use putty. So let me connect and show you. I'm trying to make it a little big. It will be easily visible to you. See the difference. It gets a little better. Now, this is, I'm connected to my Sunnyvale cluster. That's the name of my cluster here. And if I just for your knowledge, just if I say cluster show, see how it shows me that there are 2 nodes working perfectly fine, healthy. Now I will say, show me my vServers. Please remember, in command line, if you type SVM, it will say, what do you mean by SVM? Okay, so remember, SVM is the new term for vServers. In the graphical interface, it shows up SVM, but on the command line, you still have to remember your command vServer show. And notice it shows me all these data SVMs which were being shown in the graphical interface. But along with that, if you remember, I mentioned that if I say cluster show, I've got 2 nodes, Sunnyvale NAU01, 02. So I should have 2 node SVMs. And since it's one cluster, I see 1 admin SVM. In order to see this, I had to go to command line and see that from there. Okay, now let's see how you can still use putty to go ahead and say vServer create, but you should know the right commands, the right options. Okay, so how you are good at it. Otherwise, if you come on the graphical interface, you go to the storage node, expand it, and then go to SVMs, and this is where you say create. When you say create an SVM, the screen will prompt you for some choices. Obviously, the first thing is the name of my. Now be careful. When you are creating SVMs, they are for the entire cluster. So make sure that the names you give to your SVM in a cluster are unique within the cluster. Okay, so be very careful. As a cluster admin, you should know that you can manage certain things are done on a node specific, certain things are done on cluster. So SVMs are for the entire cluster. So there is again lots and lots of characteristics, guys, attached to SVM, like I mentioned, but right now I'm giving you the name of SVM, and I'm planning to use a volume. I will be attaching a volume to this SVM. And another important thing which we mentioned in our presentation is that we can pick up the protocols. Can anyone think of why I can't see fiber channel? CIFS and NFS are my NAS protocols. iSCSI is one of my SAN protocol. Can anyone think of why not fiber channel? If you know a little bit Netapp and any protocol doesn't show up, what comes in your mind? If you don't see all the protocols, that means, anybody wants to guess? Okay, that means that the protocol is not licensed. In our case, in this cluster, we have 3 licenses. Let's say I'm planning to host some data in my SVM for my Unix or Linux clients. So I only picked up NFS, but if I wanted, I can choose more than one protocol, okay? And when you say submit and continue, it will try to create this SVM for you. Like I'd say, is creating SVM with the name you mentioned. And it will ask you, see, we are telling that we want to create an SVM. It says, would you like to attach it to a LIF? Now, either you have to tell where is the physical port. Now, that is the reason you should know that this SVM is actually going to serve data on, like, let's say volume 2 or volume 3, and you will have to, like, let's first of all say that we would like to. Now, guys, again, when you create LIFs, there is another big discussion on that. you will always have to assign an IP address, a logical IP address to your live. There are two options. Either you can assign a manual IP address, which means without a subnet. If I say assign an IP address using a subnet, think about subnet like a DHCP. So there is already a default subnet, or you can create a range of IPs and it will pick up one IP from that particular range and assign it to the port. Now, where is this SVM going to serve data from? I know it's on node 1. So the volume is actually hosted on node 1, and I can pick up a port, the physical port on that particular node. So this is the reason, guys, you will have to be doing all the planning before you just come in and you set it up. You can also delegate control to a admin, or you can make an admin for that particular SVM and assign him a password that you can log in, and you have control over this SVM. And when you say create, it will actually show up here in a minute, SVM test. Right? So guys, again, there is a lot you can do. You can go back to the settings and you can make changes. You can add stuff. You can add more volumes. And if you go to volumes, these are your physical volumes, which are actually there. If you notice, it will always tell you, remember, if you create a volume, it has to be existing inside an SVM, because how is it going to be served otherwise? So notice that whenever you look at the volumes, it will always say volumes on SVM. Okay, and did you notice something, that when I created an SVM test, it automatically created a volume for it? Wait, I didn't make this volume, because this is what we call as a virtual root volume. After this, when you create a new volume, you can associate it with your SVM and then decide how you want it to be junctioned, or what path. Is it directly under the root, or my root already has wall 1 and I want the other volume to come under wall 1? So that is how you create a path. Okay, so again, guys, a lot more to talk, but like I mentioned that, you know, there is some time limit also, and the main purpose was to tell you that SVM plays a very, very important role, because in a cluster, we cannot serve data to the end users until and unless we create what we call is a data SVM. Does it make sense? Yes, guys, any questions you have? Any questions? Any questions? So I'm still here. I'd like to give it to Anas. Are you there? If you would like to tell them or say something.
Yeah, I think we haven't got any questions from anyone, so I believe you demonstrate very well. So everyone, you know, has got your point. So
But
guys,
again, you know, guys, please feel free, like if you have any simple question as well, because learning is always like starts from scratch. So, you know, don't hesitate. You can send us your questions. Yes, Anas, sorry.
no, I don't think we have any questions. So yeah, we are good. So is that all from your side, Deepika?
Yeah, I just gave them a brief overview. So I was waiting for some questions. I kept like another 5 to 10 minutes at the end, but looks like there's no question. So
Yeah. So guys, I believe you know, we have. Are there any questions? Yeah, there are two questions. So
sure, I'll look at
one
it.
is like, once a SVM is created, can you change the protocols?
Yes, it's all flexible. It's a very good question. I don't see it here somehow. Wait, I don't see that question here, guys. Maybe I'm not the host, Anas, that's why.
Yeah, in Q&A you can get it. I mean,
Okay, anyhow, I can answer the question. I heard it. So guys, this was a very good question. What actually happens, like I mentioned, it's a big discussion when we talk SVM. So what we do is, when we create lifts, we assign a policy of failover, which means that lifts are smart enough that if you are pointing to a lift which points to a node on node 1, and node 1 is down for some reason, there are policies which we assign which will automatically try to go to node 2 and get to the data. So, you know, that is how the fault tolerance come into picture. So there is a lift failover policy which will redirect the lift to another physical port and get you to your data. Because the concept is, in a cluster within a pair, when one node fails, the other node takes over and gets to the data. You're having issues submitting comments and questions here. Okay. Charlie, can you see that, Anas? Actually, I'm
Yeah. The other question is, the Paul is asking that first we need to create aggregate, then SVM, then assign volume, and then lift, right?
aggregate is the hardware level, yes. Aggregate will be there, then you create a volume, then you link it to an SVM, and yes, lift, yes.
All right. So yeah, that's the
But
hierarchy.
aggregate is mainly organizing the disks. And on aggregate, you create various volumes. Yes, the very first thing you would do is aggregate, volume, SVM, lift, and then you let people serve data.
All right. So Charlie is saying that I'm having issues submitting comments and questions here. Never mind, working now. All right. Charlie, if you have any questions, you can write directly here in the
Or you
Zoom.
can give it to me also. It's okay. Like, you know, if you put it on the chat window, you should see me also, I guess. I don't know.
Yeah, they can see you. I mean,
Somehow I don't see, if I go to my chat, it's in front of you, I'm sharing the screen. I don't see any questions on us. See, it's just,
now you can see, I believe, question Q&A.
okay, yeah, now, okay. Here you go.
Okay, we have a third question.
So we have a
Okay.
third questions there. Yeah.
Okay, so first of all, once an SVM is created, can you change the protocols? Yes, you can. So first, it's creating aggregate, then SVM, assigning volume. Yeah, you're right. I mean, volume cannot exist without an aggregate. That's true, Paul. Then the next question is, do databases have to be shut down when updating from ONTAP 8.2? Now, what happens is that if you're using a pair, what we do is we only update one node at a time in a pair. So when you are updating one node at a time, the other node is still serving the data. I'd like to show you something, guys, looking at these questions. Just a quick overview, because sometimes it's not clear. Guys, this is a very important thing to understand, that when you are talking about a cluster, it is actually two nodes, node 1, node 2, connected through HA Connect, HA Interconnect, I would say, and these are my shelves. So a very important discussion is that every node is connected to his own shelf and his partner's shelf. This is very important for you to understand. But when everything is normal, operational, node 1 can only see shelf 1. He will not be able to see shelf 2 if node 2 is up and running. It is only when node 1 fails, because you are upgrading it from 8.2 to something else, or any reason, node 2 gets dual ownership of node 2 and node 1, which is called the takeover part. And this is the time when this link to shelf 1 is operational, and when clients try to reach node 1 and they're redirected to node 2, they can still access the data from shelf 1. Is it making sense? So if your database was here, it will be still working, provided you have at least a pair of cluster. If you only have a single node cluster and you need to upgrade, it will be disruptive. Because if the node fails, everything is gone. But if it's something like this, that you have at least a pair, we always do one node at a time. We will never bring both the nodes down when it's maintenance or upgrade. Does it make sense? Yes, you're right. You're right. There are some exceptions, that there would be a slight glitch, especially with SIFs. We have seen that it just disconnects and then you will probably have to connect back. Yes, there are SIF connections which have proven to be having slight issues, but yeah, you will have to manage it in a way. You're right. There are some exceptions to it, but it is mostly non-disruptive. Like, you know, with other connections like NFS and other people, they have not given us any feedback on breaking. But SIFs, yes, it does disconnect and you have to connect back. But when you connect back, technically this is serving you from here, which is transparent. Okay. Any other questions, guys? And remember, like I mentioned, when it comes to the networking piece happening in our cluster, there's a lot of concepts which we have to understand. What is an IP space? What is a subnet? What is broadcast domains? That's altogether another topic in itself, which is like how you would do your networking inside the cluster, which also SVMs have to use, because SVM is pointing to the network inside the cluster. So that is another discussion, which the more you know, the better it is, but we didn't go over that piece. That's mainly how to do the networking part in the cluster. So that's where these concepts come into. Any other question, guys? Good. Any question from the slides or anything else you would like to ask? Okay, I see one more. How can you tell when a physical Ethernet is overtakted? Very good. Do you mean when it's not using and it's being redirected? Is that what you mean? That it's being redirected? As a cluster administrator, as overassigned, that all depends. Like I said, if this is all planning, if you put too many things like going to one port, then definitely you will see a glitch. But we plan it in a way that we get expansion slot and we add more ports. Okay, if that's what is, or we can create an interface group and you can let multiple lifts point to the group. Yeah, you're right, but yeah, you're right. But again, you have to be careful that you don't want them to be overutilized, because you don't want, if there is a problem, you know, they're like, we don't want to sacrifice over the performance piece. So you do have to worry about how you set up your networking. And like I see, what I was saying, I thought was that what if your physical port which Lift was pointing is not working, then in that case, what actually happens is that if you go in and you look at your ports, when you look at your network interface show, it will tell you that this Lift is not using the home node. It is using like home node false, which kind of tells me that this Lift, when it was created, it was pointing to a port on node 1 and it redirected to node 2. So it is serving data to the clients, but not from the home node, which kind of tells me that the Lift failed over to another node. So those are different ways for storage admin to troubleshoot and come to the conclusion that, you know, there was some issue. But we also have to make sure when the original node comes back, it fails back and it's back to home node. So those are the things. Yeah, I mean, like this question again, like I said, you know, you do want to make sure that it's not overutilized, but there are tools like Unified Manager, if you've used, those are the tools which you can use to monitor that how much percentage is being utilized. And then auto support is an excellent way. They will definitely every Sunday around midnight, Netapp runs a report on your filers and they do a good job telling you that, you know, we feel that your controllers are more overutilized because, you know, that way, you know, they most likely want you to add another pair to your cluster because it looks like you have got a lot, way more pressure than you were expecting. So they do a good deal in giving us guidelines on these kind of things. So even if you're not monitoring that, they might give you in the report, which is generated every Sunday midnight around that time, that, you know, we think it's the controllers which are overloaded, or you need more disks, or you need more spares. Okay. Anything else, guys? Well,
Nice.
you're welcome, Paul.
Nice to have so many questions at the end.
I'll give it to Anas, guys. Good luck and thank you so much for joining us. Thanks a lot. I'll give it to Anas.
Yeah, I would say thanks a lot for joining this webinar, and We have lost. Oh, yeah, it's all good. So, Mr. Pandey, thank you very much for your comments. And we have also Expert Connect. If you can join us in the Quick Start website, the Expert Connect thing. So you can leave your questions, and even you can post your answer over there if you're expert on the domain. So yeah, it's a very good and handy feature of Quick Start website. Moreover, we have every week class of ONTAP cluster administration. So you can join this class and get the feature and get to know about each and everything about this ONTAP. So yeah, we are good. Thank you so much, Deepika, for your time, and thank you so much for joining this webinar, guys.
Thank
Bye.
you, guys.
Have a